Hi guys, today I will be showing you guys logic gate analysis, but basic introduction level. So using live wire. Yes, this is straight to business AND gates, and this is NOT gate symbol, and this is NAND gates, and basically, okay, we have OR gates, OR, NOR, AND NOR gate, XNOR gates, and XOR gates. Now this is basic AND gates, NOT gates, which is sometimes called inverted gate, and this is OR gate. This is NAND, this is XOR and XOR, XNOR and XOR. Okay, so this is the combination of this and this and this. I will explain it in detail when we get back to the full video. So, and we'll be using input signals from here. So input for the boards, and this is output. So this is how you pick your output and input. You connect the output to here. This is the output. Connect the input. So I'll be showing you guys how to stimulate with it and get your results for your circuitry logic analysis. So you connect the output here, same here. So does it. So you stimulate it. So when it's on red state, it's on. When it's not red, it's off. So let's go straight to the AND gates. So we'll be starting from AND gates today. So this is our AND gates, and we'll be stimulating the first result. The first result is going to be input 1, which is the first input up, and input 2, which is this, and we'll get an output. So we'll on the input 1 and we stimulate. So you could see it's still in off state. Now the AND gate means, in literal man's term, multiplication. So this is 1 times 1, 0 equals to 0. Now we'll be stimulating the input 2 and offing the input 1. So this is input 1, input 2 on state, which is 1. Stimulate, we still have 0 as our result. So 1 times 0 is still 0. So when we on both, we have 1. So 1 times 1, 1. And when we off both, we have 0. So that was how you generate results for this. So note, AND gate is multiplication. So we move to the next. This is our inverted gates or NOT gates. So it has 1 input, 1 output. So 0 times 1 supposed to give us 0, but since it's a NOT gate, it's inverted, it gives you opposite of its normal answer, so it gives us 1. So let's stimulate and be sure. This is on state, which is 1, and at our output we have 0. So 1 times 1 should be giving us 0, 1 outside, but it's giving us 0 because it's a NOT gate inverted. So when we are offing this, it's giving us 1 on state. So this is NOT gate. And the next is, so in the next video I'll be shooting on logic analysis. We'll be doing a combinational circuit combining the NOT gate, AND gate, and other circuits together. So let's go to the NOR gate. Now this is a NOR gate, is opposite of an OR gate. Okay, let me go to OR gate first, so I will explain how an OR gate works for you to really understand. So this is an OR gate. OR gate is additional. That is additional from basic elementary mathematics. So this is 0 plus 0 gives you 0, and 1 plus 0 gives you 1. So you can see 1 plus 0 gives you 1. 1 plus 1 gives you 1. So this is how the OR gate works. OR gate. So then let me go back to the NOR gates now. So this is our NOR gates. It gives you an opposite of the answer of an OR gate. So this is an OR gate symbol with a NOT gate beside it. So this dot means a NOT gate is attached somewhere here. So it's an OR gate IC. So this is on state. Let's stimulate on state. So 1 times 0, 1 plus 0 is supposed to give us 1, but because of the NOT symbol here, it's giving us 0. So 1 plus 0 is supposed to give us 1, but it's giving us 0. 1 plus 1 should be giving us 1, but it's giving us 0. 1 plus 1 gives us 0. You could see output 0. So but when you put 0 plus 0 is 1. So in this NOR gates circuitry, all input signals need to be in off state for you to have an output signal from your IC. So the next is XNOR gate. So in this one, you need to have all input devices on the same position. So if you are having on state, the both input signals supposed to be on for you to have an on output. For instance, let's stimulate. Now this is on, where input 1 is on, output 2, input 2 is off, and we're having 0. So this is on the normal OR gates. 1 plus 1 plus 0 is supposed to give us 1. Because of the NOT symbol here, we're still going to have 0. Now, but the XOR needs both 1 plus 1 still gives us 1. This is an XOR. This is on state 1. Now 0, no input, off state input 2, off state input 1 still gives us 1. So this is how XOR works. You need all inputs be in the same state before it could work. So this is XOR. Now the one we just did was XNOR, and this is XOR. Now in XOR we have input on, this is on state 1 plus 1, because there's no NOT symbol here, so we're having 1 output on. But 1 plus 1, now in this case the difference between the XOR and the XNOR is that when both input signals are in the same state, we have 0, we have off state. So for instance, both inputs are on, we have off state at the output. So, and when you off both, you still have off state at the output. So you need one to be different from the other input for you to have an output of on state. So this is basically introduction for our logic analysis system. So in the next video we'll be doing pure proper circuitry of all combination of the XOR, NOR gates, AND gates in a full circuitry with multiplications to give us an output. So you watch out for that video. It's in the next class. So I'll be dropping a link on how to download this software I'm using, the LiveWire application. You could check on the description of the video. You get the link to download it. It's free and you could use it. Thank you.